Hey everybody, in this video we are going to simplify the trigonometric expression you see on your screen now, which is the product of conjugates, sine theta minus 1 and sine theta plus 1. As soon as you see conjugates, which is the same expression except the middle sign changes, you keep the beginning, change the ending, like you conjugate your verbs in your foreign language class, right? When you see conjugates being multiplied, you should just go ahead and FOIL them every single time, or distribute, multiply, whatever. Every time you multiply conjugates with each other, you will end up with the difference of two squares. In this case, we will be able to reference fundamental identities such as reciprocal, quotient, or Pythagorean identities to continue with simplifying this. So if I multiply first times first, I get sine theta times sine theta, and we write that as sine squared theta, not sine theta squared. Outer is plus sine theta. Inner is minus sine theta. Bye-bye. Adios. Last times last, minus 1. Now, you want to really be careful with this particular situation because a lot of people do this one backwards, and we don't want to do that. So maybe go back and look again. Sine theta, sine squared theta plus cosine squared theta, the Pythagorean identity, equals 1, right? If I bring this 1 over to this side, I'll use subtraction. That will get me sine squared theta minus 1 on one side, right? That cosine squared theta, however, will have to get to the other side. Also, using algebra, you don't just pick things up and put them down. We subtract that over, and that means it equals negative cosine squared theta. So could I really just go right now to, there we go, negative cosine squared theta? I mean, I think so, right? This is like an earlier type of example. It's kind of a little light. If you wanted to, could you also take the 1 and swap that out for sine squared theta plus cosine squared theta? Sure. If you chose to do it that way, you would get sine squared theta minus the quantity of sine squared theta plus cosine squared theta. If you don't have those parentheses, you're going to regret it because you need them there to make sure you distribute properly. Sine squared theta minus sine squared theta minus cosine squared theta. That cancels out, becomes 0 for that part, and we are left with negative cosine squared theta. Either way we do it, we get negative cosine squared theta. This, in fact, again, was the Pythagorean identity. There are 2 other iterations that we tend to reference, but that is the classic original form. If you're happy and you know it, thumbs it up. If not, thumbs down. But look, Dallas here says you should give thumbs up, pause up. Yeah, I know. Questions, comments, concerns in the comments, please. Description box has links to tons of other examples. There's going to be a click through at the end of this for the next video in the playlist, or you can go to the playlist and pick whatever you want. Adios.